A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was looking at the TIOBE index yesterday, and something jumped out at me that I think a lot of people are overlooking. For years, we have talked about Python as this unstoppable juggernaut, the language that ate the world. But the numbers for March 2026 tell a different story. Python's market share dipped below 22% this month. To put that in perspective, it was nearly 27% back in July of last year. That is a massive 5-point drop in less than a year.
It is a fascinating shift, Korn. Herman Poppelberry here, and I have been obsessing over those same charts. We are seeing what looks like a healthy plateau, or perhaps a market correction. The industry is finally moving past the one language to rule them all phase. Today's prompt comes from Daniel, and it is a deep dive into why languages like R and Julia are not just surviving in Python's shadow, but thriving in very specific high-stakes niches. Even with Python's massive footprint in artificial intelligence and data science, the cracks are starting to show.
It is funny, because if you go back to our episode 1021, where we called Python the accidental king of AI, the narrative was that Python had essentially won the war. If you were starting a career in data, you learned Python, and maybe you glanced at R if you were in academia. But Daniel points out that R has jumped from 16th to 10th in popularity over the last 12 months. That is a significant comeback for a language that people were calling a legacy tool 5 years ago. We are seeing a real polyglot shift in 2026. Being a single language specialist is becoming a major career liability.
That is a vital observation. The comeback of R is driven by factors that Python simply cannot replicate, no matter how many libraries people write. One of the biggest is what I call the regulatory moat. If you look at the pharmaceutical industry, biotech, or clinical research, R is deeply embedded in their reporting pipelines. The Federal Drug Administration, or FDA, has statistical computing guidance that explicitly references R and SAS. When you are dealing with multi-billion-dollar clinical trials, you do not switch your statistical backbone because a new version of a Python library came out on GitHub. You stay with a tool that has decades of validated, reproducible results.
So it is a matter of trust and institutional momentum. But it is more than just being grandfathered in, right? I've used both, and there is something about the way R handles data that feels fundamentally different from Python. In Python, you are almost always reaching for an external library like pandas or polars to make the language do what you want. In R, the statistical thinking is baked into the core of the language itself.
You hit on a key point there. The tidyverse ecosystem, which was largely championed by Hadley Wickham at Posit, remains the absolute gold standard for exploratory data analysis. When you use tools like dplyr or ggplot2, the grammar of data manipulation is incredibly expressive. There is a fluidity to it that Python struggles to match. In Python, you are often fighting the object-oriented nature of the language to perform simple statistical transformations. R treats data frames as first-class citizens. It is a language designed by statisticians for statisticians, whereas Python is a general-purpose language that happens to be good at math.
I have always felt that ggplot2 is the one thing Pythonistas are truly jealous of. I know Seaborn and Matplotlib have come a long way, but for publication-grade visualization, R still feels like it is playing a different game. If you look at the charts in a paper from the IPCC, or a report from the CDC, you can almost always tell when it was done in R. The level of detail and the ease of layering complex data is just unmatched.
It really is. And we have to give credit to the rebranding of our studio to Posit back in 2022. That was a brilliant strategic move. They realized that the future is Polyglot. They started supporting Python and developed the Cordo publishing system to bridge the gap. but they did it in a way that preserved that R-centric workflow of high-quality, reproducible scientific communication. If you are working at a place like the CDC, you are likely living in that R ecosystem because the visualization and reporting tools are the primary way you communicate life-saving information to the public.
Let us pivot to Julia, because that is a completely different beast. Julia was built specifically to solve the two-language problem. For those who might have missed our discussion on this in the episode about the Rust Revolution, the two-language problem is a massive bottleneck in scientific computing. It is when a scientist prototypes a model in a high-level, easy-to-read language like Python or R, but then realizes it is way too slow for production. So, they have to hand it off to a software engineer to rewrite the entire thing in C++ or Fortran.
And that handoff is where the bugs creep in. Julia's promise was to be as easy to write as Python but as fast as C, and in 2026, we are seeing it live up to that in some pretty spectacular ways. In high-energy physics benchmarks, Julia is scoring 10 to 100 times faster than Python for numerical work. It can match C or Fortran for things like random matrix multiplication. The Federal Aviation Administration, the FAA, is using Julia for air traffic control optimization in their next-gen systems. That is a high-stakes, real-world production deployment where you cannot afford a rewrite, and you cannot afford a slowdown.
If Julia is that fast and that easy, why are we not all using it? Why is the adoption still relatively narrow compared to the Python ecosystem? I mean, if I can get 100 times speed up, why would I ever touch Python again?
There are a few major friction points that the Julia community is still wrestling with. The most notorious one is the time to first plot problem. Because Julia uses just-in-time compilation, the first time you run a script in a session, it has to compile all the functions from scratch using the LLVM compiler. This can lead to a startup latency of 30 to 60 seconds just to generate a single graph. For a data scientist who is used to the near-instant feedback of a Python notebook or an R console, that feels like an eternity. It breaks the flow of exploration. You want to iterate, not wait for the compiler to warm up.
I can see how that would be a deal breaker for casual users, but beyond the latency, there is the massive gravity of the Python ecosystem. We talked about this with the rise of large language models.
The ecosystem lock-in is a huge factor. Think about the billions of dollars invested in PyTorch, TensorFlow, Hugging Face, and LangChain. Those are all Python-first libraries. If you want to use the latest large language model or a specific computer vision architecture, it is probably already optimized for Python. Moving to Julia means you have to either use a bridge like Python call, which adds complexity, or wait for the Julia community to build a native version. A 2025 paper titled "The State of Julia for Scientific Machine Learning" pointed out that while Julia is growing, it is struggling with debugging infrastructure and that Python interoperability.
We talked about JAX in a previous episode as a competitor to Julia in the scientific machine learning space. JAX is Google's attempt to give Python users that high-performance, compiled feel without leaving the language. How does Julia's scientific machine learning ecosystem, the SciML stuff, hold up against something like JAX in 2026?
It is a fascinating rivalry. JAX is incredible for neural networks because it compiles to XLA and handles transformations like differentiation and vectorization beautifully. But Julia's SciML ecosystem, led by people like Chris Rakakis, is much broader in scope. It is not just about deep learning, it is about differential equations, physical modeling, and combining those with neural networks. If you are doing climate simulation or modeling the folding of a protein, Julia's native support for complex mathematical structures is often more robust than what you can piece together in JAX. JAX is a tool for machine learning. Julia is a language for science.
That is a helpful distinction. Julia is for the creator of the mechanism, Python is for the consumer of the mechanism. But let us talk about the job market, because Daniel mentioned this polyglot trend. In 2026, the most valuable candidates are not the ones who just know Python. Employers are looking for people who can bridge the gap. They want someone who can do rigorous causal inference in R, but then wrap that model in a scalable data engineering pipeline using Python and maybe a bit of Rust.
I am seeing that everywhere. Python appears in 86% of data science job postings, but R is still in 50%. That is a huge overlap. It means companies are not choosing one or the other, they are using both. They want analysts who can use the tidyverse for deep statistical discovery and then hand off a clean, validated model to the engineering team. If you only know Python, you might miss the statistical nuance that an R user would catch. If you only know R, you might struggle to deploy your model at scale. The real power is in knowing which tool is right for which part of the problem.
It makes sense. Being a single language specialist is becoming a liability. If you are in quantitative finance or bioinformatics, learning Julia could be a massive career move. You are dealing with datasets and simulations where that 10 times speed up really matters. It is the difference between a model that runs in an hour versus a model that runs in 6 minutes. That changes how you work. It allows for a level of experimentation that is simply impossible in a slower language.
And for R, it seems like if you are going anywhere near pharma, biotech, or public health, it is still a mandatory skill. You cannot just walk into a clinical trial environment and expect to do everything in a Jupyter notebook with pandas. They have established protocols and validation steps that are built around the R ecosystem. There is also the human element. The R community is incredibly welcoming and focused on education and literacy. The tidyverse is not just a set of tools. It is a way of teaching people how to think about data. That is likely why it is making a comeback. People are realizing that as AI generates more code, the value of the human being in the loop is their ability to interpret and validate the results. R is designed for that kind of critical thinking.
So, if we were to give a listener a decision matrix for 2026, how would we break it down? When should they lean into these alternatives versus sticking with the Python default?
I would say the Python first rule still applies for general purpose work. If you are building a standard machine learning pipeline or you need to integrate with a lot of web services, Python is your best bet. It is the glue that holds the modern tech stack together. But you should branch out to R if your primary goal is statistical discovery or if you need to create high-stakes visualizations for publication. If you find yourself spending more time cleaning and exploring data than building models, the tidyverse will save you hundreds of hours.
And Julia?
Julia is for the performance-critical work. If you are writing custom algorithms from scratch, or if you are working with complex systems like differential equations where Python speed becomes a bottleneck, Julia is the answer. It is also worth learning just to understand the multiple dispatch paradigm. It changes how you think about code architecture in a way that will make you a better programmer even when you go back to Python.
That multiple dispatch point is interesting. In Python, you are often doing these complex checks to see what kind of object you have before you decide what to do with it. Julia handles that at a language level, right?
It does. It essentially looks at the types of all the arguments in a function and picks the most specific version of that function to run. It sounds technical, but it makes the code much more composable. You can take a physical model written by one person and a differential equation solver written by another, and they just work together without any extra glue code. That is the magic of Julia that people miss when they only look at the benchmarks. It solves the architectural two-language problem, not just the performance one.
It feels like we are moving away from the era of the monoculture. For a while, the tech world was obsessed with finding the one language that could do everything. But the reality of 2026 is that our problems are getting too complex for that. We need the precision of R, the speed of Julia, and the versatility of Python all working together.
I agree. And it is not just about the languages themselves, but the philosophy behind them. R is a language for scientists. Python is a language for developers. Julia is a language for mathematicians. Depending on which hat you are wearing that day, you might need a different tool. I suspect the dip in Python's market share is not a sign of its decline, but a sign of the industry maturing. We are becoming more discerning about our tools. We are realizing that a Swiss Army knife is great to have in your pocket, but if you are preparing a 5-course meal, you want the specialized kitchen knives.
That is a perfect analogy. And we should mention that the interoperability is getting better. Tools like Reticulate in R and Julia Call allow you to run code from other languages within your primary environment. You do not necessarily have to choose one and stay there. You can have a Python script that calls an R function for a specific statistical test, then passes the results to a Julia module for a heavy-duty simulation.
That is the ultimate power user setup. but I imagine the debugging for that kind of polyglot pipeline is a bit of a nightmare. That is one of the valid criticisms in that scientific machine learning paper Daniel mentioned. When you have multiple languages interacting, the error messages can become quite cryptic. We are still in the early days of making that experience seamless, but the potential upside is so high that people are willing to deal with the friction.
What about the future of the two-language problem? Do you think Julia will eventually solve it for the mainstream, or are we just going to keep rewriting things in Rust or C++? We did a whole episode on the Rust revolution recently, and that seems to be another piece of this puzzle.
Rust is definitely taking over the system level work. A lot of the new high-performance Python libraries like Polars are written in Rust under the hood, so in a way, the two-language problem is being solved by hiding the second language. You stay in Python, but the heavy lifting is done by a Rust core. Julia's approach is different because it wants the user to be able to see and modify that core in the same language they use for the high-level work. It is a more transparent approach, but it requires a bigger shift in the ecosystem.
It seems like Julia is more of a long-term play for the scientific community, while the Python plus Rust combo is the pragmatic choice for the industry right now.
I think that is a fair assessment. But if you are a student or a researcher today, learning Julia gives you a superpower. You can build things that are simply impossible to do efficiently in Python. And as the tooling improves, especially around that startup latency, I believe we will see Julia continue to eat away at those high-performance niches.
Let us talk about the career advice side of this for a second. If someone is listening and they feel like they're starting to hit a ceiling with their Python skills, which direction should they go first, R or Julia?
It depends on their interests. If they are drawn to the analytical, storytelling side of data, I would say R without hesitation. The ability to create beautiful, interactive dashboards with Shiny and the clarity of the tidyverse will make them a better analyst. If they are more interested in the engineering and simulation side, or if they want to get into quantitative finance, then Julia is the way to go. It will push their understanding of computer science much further.
I would also add that they should not ignore the regulatory aspect we touched on. If you want to work in a field like healthcare or government policy, having R on your resume is still a massive signal of credibility. It shows you understand the rigor that those fields require. Most of the cutting-edge statistical research is still published in R first. If you want to use a method that was invented 6 months ago, there is a good chance there is an R package for it, but the Python implementation might be a year or two away.
It is interesting how these languages have these distinct personalities. Python is the friendly, helpful neighbor who knows a little bit about everything. R is the precise, slightly eccentric professor. And Julia is the young, ambitious athlete who is trying to break all the records. And they are all living in the same neighborhood now. The competition between them is actually good for everyone. Python is getting faster because of the pressure from Julia. R is getting better at production because of the influence of Python.
Before we wrap up, I want to touch on one more thing Daniel mentioned, the FAA's use of Julia. It is such a fascinating example because air traffic control is one of those systems where failure is not an option. You need absolute correctness and extreme performance. The fact that they chose Julia over a more established language like C++ says a lot about the maturity of the language for high-stakes work.
It really does. It shows that when you have a truly complex optimization problem, the ability to express it clearly in a high-level language while maintaining performance is a safety feature. It is easier to verify that the logic is correct when the code looks like the math it is representing. That is the real power of Julia in that context. It reduces the cognitive load on the engineers, which reduces the chance of a catastrophic bug.
That is a powerful argument. It is not just about speed. It is about the bridge between human thought and machine execution. Whether it is R, Julia, or Python, we are all just trying to find better ways to talk to the machines and make sense of the world.
It is the alignment of the human's mental model with the computer's execution model.
That feels like a great place to leave it. We have covered the regulatory moats of R, the performance peaks of Julia, and why the polyglot future is probably the most exciting path for anyone in this field. If you are a Python developer, do not be afraid to be a little curious about what is happening in those other ecosystems. You might find a tool that changes how you think.
And if you are an R or Julia user, keep pushing the boundaries. The rest of the world is watching and learning from what you are doing.
This has been a deep one. Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power the show. If you are looking for a serverless platform that handles the infrastructure so you can focus on the code, definitely check them out.
If you enjoyed this exploration of the language landscape, we would love to hear from you. Search for My Weird Prompts on Telegram to get notified when new episodes drop and join the conversation. We are always curious to hear which tools you are using and why.
This has been My Weird Prompts. I am Corn.
And I am Herman Poppleberry. We will see you next time.
Take care.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth, from man, from long-eared host. My Weird Prompts, until next time, stay curious, keep weirding.